Hi everyone. In this video, I'm going to work the problems that we discussed on your fraction worksheet. This is because we forgot to record the class today, or was because we planned on doing breakout rooms, so the class didn't get recorded. I've included a copy of the worksheet here, but I don't have a lot of space, so I'm going to work on these problems below. Now, the first question talks about Nick and fertilizing the acres of soccer fields. Hopefully, after you read that question, you recognize it as a multiplication problem. So it's our job to multiply 12 acres times 9 3/4 bags of fertilizer, 9 1/3 bags of fertilizer per acre. So how do we multiply mixed numbers, or mixed numbers times a whole number? Probably the easiest way to do this is to use 12 over 1 and then to turn this mixed number into an improper fraction. When I do that, 3 times 9 is 27 plus 1 is 28. I get 28/3. And then again, the easiest way to multiply this would be to cancel this 3 into 3 once, 3 into 12 4 times, and 4 times 28 is 112. So would answer this by saying that it requires 112 bags of fertilizer. The second one talks about yards of material, and we know that we have 54 1/4 yards. But we need to cut that into pieces that are 3 1/12 yard long. Now, hopefully you recognize that this particular problem is going to be a division problem. If you don't, you can think about actually cutting that. So if I have that many yards of material and I start making those cuts, that's going to be repeated subtraction. And we recognize that repeated subtraction is division. So how do we divide 54 1/4 divided by 3 1/12? Well, these are mixed numbers, so really we should probably turn these mixed numbers into improper fractions in order to do the division the easiest. So 54 1/4 becomes 217 over 4, and 3 1/12 becomes 37 over 12. Now, there are a couple different ways to actually do this division. You can either use the flip and multiply technique, which will work. That would be 217 over 4 times 12 over 37. You can cancel, and you'll come out with 651 over 37. Or you can go a different way, and you can get common denominators here. To do that, that first fraction has to be turned into twelfths. So you could take 217 and multiply it by 3, getting 651. And divide that by 37 over 12. And we know we just divide the numerators. So it's 651 over 37. Either way, whichever technique you choose, you're going to come out with this kind of odd fraction of 651 over 37. So how many pieces are being cut at 651 over 37? Well, if you actually do that math, the 651 divided by 37, you get 17 something. So I think of it as a division problem here. This fraction itself becomes a division problem, which is 651 divided by 37. I know that that equals 17 with some remainder. So if we use our calculator to help us, 17 times 37 is 629. This subtraction, 651 minus 629, gives us 22 left over. So that means that there are 22 pieces out of 37 pieces that are left over. So we know that we can cut 17 whole 3 1/12 yard chunks. We know that we're going to get 17 of these cut. So that first answer on our page will be 17. So it says, how many pieces can she cut? She can cut 17 pieces. But then the real question is, how many yards of material are left over? And that's a little bit harder to think about. We know that there's not an entire group of 3 1/12 yards left over. But how much of that chunk of 3 1/12 yard is left? Well, there are 22 37ths of that chunk. So I say to myself, 22 37ths of 3 1/12 are left over. But we remember from before that 3 1/12 is the same as 37/12. So there are 22/37 of 37/12 left over. Quick multiplication gives me 22/12 or 11/6. That tells me that there's actually 11/6 of a yard left over. 11/6 as a mixed number would be 1 5/6 yards of material left over. Comments or questions, please feel free to ask. Maybe you and I can talk about this individually. Next up, we have to worry about the ratio of boys and girls in Mrs. Good's class and Mrs. Bressy's class. So let's take a look at question number 3. Now, the actual question that's being asked here is how many boys are in Mrs. Bressy's class, but there could have been a lot of questions asked about this. So what I did for this particular one was make a little table. I have Mrs. Good here, and I have Mrs. Bressy here, and then I have boys, girls, and total. We don't know about Mrs. Good's class, how many boys, how many girls, and how many total. All we know is the ratio, boys to girls, which is a part-to-part ratio. So we know that there are 3 boys for every 5 girls. Again, that could mean that there are more than 3 boys, but the ratio of boys to girls is 3 to 5. That's in Mrs. Good's class. In Mrs. Bressy's class, we do know an absolute amount. We do know that there are absolutely 15 girls. So the question is asking how many boys are there? So the first thing I do is I say, well, I know these ratios are the same. If you read the problem, it says that the ratios are the same. And this is boys to girls. We know that there are 15 girls, so how many boys? You can use scale up, scale down, you can use cross products, whatever it takes, but you know that this was times 3, so this is going to be times 3, so that answer to the question that was asked is 9. But keep in mind that there could have been a lot of other questions asked. You could have been asked about how many children are in Mrs. Bressy's class, in which case I would have had to have added that 9 and 15 together to get 24. You could have been asked about the ratio of boys to children, a lot of different versions of this question. So I just included this table here to show you some good problem-solving techniques. If I look at question 4, it says, I have 5 3/4 pound of almonds, but I give some away, 2 1/3 pound. Hopefully you recognize this as subtraction. So I have 5 3/4 minus 2 1/3. And we know that in order to subtract fractions or mixed numbers, we need to have common denominators. I kept the 5 and got a common denominator of 12 here. That means this is 9/12. And we'll keep the 2 and get a common denominator of 12, meaning that this is 4/12. So when we do this subtraction, we can subtract those whole numbers, and then we can subtract the fractions and get 3 5/12, and then our units, of course, pounds left over. You didn't have to do it this way. You could have gone with improper fractions. If you had, you would see that you had 23/4 minus 7/3, turning that into common denominators. 69/12 minus 28/12 gives you 41/12, which does turn back into the 3 5/12. If you're looking at question number 5, this talks about people napping. And probably the easiest way that I heard from my groups to solve this is to turn the napping from 3/4 into something over 60, because there are 60 minutes in an hour. So 3/4 of an hour turns into 45 over 60 if you multiply top and bottom by 15. If you look at John, his fraction is more than 1, so obviously he napped the longest. And if you turn that into 60s, you get 70 over 60. So we know that John napped the longest. How much longer? Well, whatever 70 minus 45 is, which is 25 minutes. Question 6 talks about Alicia and some stickers. It says she gave away 24 stickers, and those 24 represented 3/5 of her total. So I wrote that 24 is 3/5 of her total. There are so many different ways to do this, and I encourage you to check the uploaded document from class today to see some of them. But one way to do this would be to say that 24 equals 3/5 of x. To solve this, I have to divide both sides by 3/5. 24 divided by 3/5 is the same as 24 times 5/3. Cross out here, and I get that there were 40 stickers in total. But that's not what the question asked. The question asked how many she had left. So if she had 40 and she gave away 24, that must mean that she has 16 stickers left. So I'm going to break this video into two pieces because this is already getting long, and I'll see you guys for the second piece.